alumina sheet, a flat ceramic plate made from aluminum oxide with a dense, non-porous microstructure that delivers high hardness, dielectric strength, chemical stability, and high-temperature performance in a single platform. This is a two-dimensional component, a thin, flat carrier designed to sit between other parts in an assembly. It is available to supply alumina sheets in purity grades from 96% up to 99.7%, with thicknesses starting as thin as 0.05 millimeters for precision applications and scaling, up to thicker structural formats. 5 properties make alumina sheet the right choice where polymers, mica, or metal plates cannot survive. First, dielectric strength exceeding 10 kilovolts per millimeter, maintaining electrical insulation in environments where polymer pads soften and break down. Second, hardness above 15 gigapascals, preventing groove formation from repeated fixture contact or sliding load. Third, thickness tolerance held to plus or minus 0.05 millimeters in precision grades, enabling repeatable clamp pressure and consistent assembly torque. Fourth, porosity below 1%. The dense microstructure resists coolant and abrasive infiltration, keeping the surface clean across service cycles. And fifth, chemical inertness against common process atmospheres and cleaning agents, so the sheet does not degrade when exposed to solvents, fluxes, or routine maintenance chemistry. For design features of the alumina sheet make it practical to integrate into assemblies. First, 3 tolerance tiers are available, plus or minus 0.05 millimeters for precision optics and insulation work, plus or minus 0.10 millimeters for electronics and fixtures, and plus or minus 0.20 millimeters for general wear liner applications, letting engineers match sheet precision directly to assembly requirements. Second, polished faces with surface roughness below 0.05 micrometers, which improves adhesive wetting and reduces edge chipping during installation. Third, chamfered edges between 0.5 and 2 millimeters minimize stress risers at corners and improve operator safety during handling. And fourth, custom machining is supported across the board holes. Slots, windows, and specialty edge profiles can be added to any sheet per drawing to match the mounting features of the target assembly. The most typical application for alumina sheet is electrical insulation in inverter drive retrofits. The problem it solves is straightforward. Inverter drive modules run hot and cycle hard, and the polymer insulation pads originally specified for these assemblies degrade after repeated thermal cycling, causing insulation leakage between live components and forcing retorque events to restore clamp pressure. The documented retrofit replaced those polymer pads with a thickness-controlled alumina ceramic sheet. 3 material and design properties drive the outcome. First, thickness tolerance held to plus or minus 0.05 millimeters keeps clamp pressure uniform across every bolted joint, so the insulation gap remains exactly as specified and torque settings no longer drift. Second, dielectric strength exceeding 10 kilovolts per millimeter maintains stable insulation even after 500 plus heating cycles, where polymer chemistry would have already broken down. And third, polished faces with surface roughness below 0.05 micrometers enhance adhesive wetting and reduce edge chipping during assembly, which protects the bond line during installation. The measured result was direct insulation gaps stayed consistent over 500 plus thermal cycles. Rework calls dropped by more than 20% and maintenance windows shortened, enabling stable module performance across production shifts.